All right, welcome back to part 2. This is basic Java syntax and semantics. Let's talk about the assignment statement or the assignment operator. An assignment in Java works like this. Have a type, an identifier, then comes the assignment operator, and then some kind of value. Now, you've got to be careful because the equal sign here is not the equal sign that you know and love from your mathematics courses. So, for example, 5 equals int x is really bad syntax. The compiler is going to complain when you do that. That's just not how the assignment operator works. In your mathematics classes, you would have variables, or you'd have equations, something like 3y plus 5 equals 4y minus 2, and you would use a series of additions, subtractions, multiplications, and divisions, and you would get an answer. That is not the equal sign that we're dealing with now. So this is an assignment operator. The left-hand side has to have the type and the variable or identifier name. Then comes the assignment operator, and then comes the value. So if I import a scanner object, scanner is the object type, reader is the identifier, then comes the assignment variable, new scanner system.in, and what the right-hand side does is it creates a location in memory for a scanner object and stores in the basic information, ties it into the keyboard. This tells me the type, the data type, that it's a scanner object, and this is the identifier. I cannot say new scanner system.in equals scanner reader. It just doesn't work. That is not the syntax. So the type, the data type, and the identifier go on the left-hand side, and the value or the instantiation of the object goes on the right-hand side of the equality. Okay, let's talk about arithmetic expressions. An arithmetic expression is nothing more than an expression that combines numerical values through operations: addition, subtraction, multiplication, division, and modulus. So I'm going to give you some examples of how arithmetic expressions work. So let's say system.out.println, and inside I'm going to print out the result of an arithmetic expression. Let's say 3 times x minus 2 times parentheses y plus z, and let's say plus 5 modulo x, and we'll call that good enough. Let's see. I didn't even use w. I got to use w somehow. So let's say divided by w. Okay. Okay, so here's an arithmetic expression. It's a set of values that are combined or linked together through the operations. And so it's going to follow the order of operations, doing grouping first, and then looking for powers or exponents, then looking for multiplication or division. Probably the only thing you might be really confused about here is what on earth is this modulus thing? Yeah, let's go ahead and explain that real quick. Let's say I have a equals 8 and b equals 3. Well, system.out.println, if I have 8 divided by 3, you're probably familiar enough to know that you're going to get a decimal number, 8 divided by 3. But this is not going to work the way you think it's going to work. And we'll get into that when we talk about mixed mode arithmetic. So what do you think I'm going to get when I say 8 divided by 3? What do you think? Let's see what I get. I get 2. And you're probably like, well, what are you talking about? I should get 2.6 repeating, right? Well, 8 is an integer, 3 is an integer, and because we're doing integer division, Java is going to return an integer, not a double. Okay. Well, we'll get into that when we get to mixed mode arithmetic, how we can actually get the answer that we should get, okay? But when I have 8 modulo 3, instead of giving me the quotient, which in this case is 2, it's going to give me the remainder. So if I took 3 and divided it into 8, it would go 2 times. And what would be the remainder? Well, the remainder would be 2/3, or the remainder would be 2. So my answer of 8 divided by 3 should equal 2 plus 2/3, or 2.6 repeating. And so that's what a modulus does. It doesn't give me the quotient, it gives me the remainder after division. And so that's how we explain the quotient. Okay, so there's your arithmetic expressions. By the way, system.out.println, even the number 5, the literal 5.3, by itself is an arithmetic expression. So arithmetic expressions are just the expressions that we're familiar with. It's the mathematics that we deal with. Okay, let's look at common operators and their precedence. When I use the word precedence, I simply mean priority. Which operators have higher priority than others? So here's the list. The top, the thing that has the highest priority, is grouping. And so grouping involves parentheses. The next item on the list is the method selector, which is the dot. Next comes unary addition, unary subtraction. Next comes instantiation. Then comes cast. Then comes multiplication. Then comes division. And finally, remainder or modulus, addition, subtraction, and the lowest level priority is the actual assignment. So the assignment operator doesn't actually kick in till the very end, after we've computed this whole thing. After that's done, then we assign it to the variable x. So okay, let's look and see how this thing would end up being calculated. First, I have to look at grouping, and so it's going to look at 5 plus 3 first. So okay, 5 plus 3 is 8. Minus 2 times 4 minus 2.2 divided by 2.0 plus 5 modulus 3 plus an integer cast of 3.14, and there we go. All right, what's next on the list? Well, I've still got more grouping. So x equals 8 minus 2 times 4 minus 2.2, which is 1.8, divided by 2.0, plus 5 modulus 3, plus int 3.14. All right. Now, the entire expression is in a grouping, but because it's the entire expression, we don't have to consider that grouping. All right, so do we have any method selectors? No, we don't have any unary addition or unary subtraction. We don't have an instantiation, but we do have a cast. Do you remember what's going to happen with the cast? It's going to drop the decimal part of the cast, and it's going to keep just the integer, so plus 3. All right, next on the list. After cast, do we have any multiplication? Yes, we do. 8 minus 3.6 divided by 2.0 plus 5 modulus 3 plus 3. Do I have any more multiplication? No, so I move on to division. 8 minus 3.6 divided by 2.0 is 1.8 plus 5 modulus 3 plus 3. Next comes my modulus. So 8 minus 1.8 plus, what's the remainder of 5 divided by 3? It's 2. Now, we have something here called mixed mode arithmetic. I have 3 ints and I have 1 double. So what does Java do when you combine arithmetic operations on ints and doubles? Well, it's pretty easy, actually. Java is going to take the type that has the most precision. And so decimals have more precision than integers do. So the final answer is going to be converted to a decimal. So this is now basically like saying 8.0 minus 1.8 plus 2.0 plus 3.0. And let's see, 8 minus 1.8. It would actually do the division first, the addition first. So 8.0 minus 1.8 plus 5.0. Then comes what? Oops, come on. Then comes x equals 8.0 plus 5, which is 13.0, minus 1.8. And then lastly comes x equals 13.0 minus 1.8 is 11.2. And so we can basically drop the 11.2. X equals 11.2. And so this is when the value of 11.2 is stored into the memory slot for the identifier X. And there we go. Let's just double check everything. 11.2. Now, looking at all these operations is not terribly exciting. I'll confess that right out front. But it's absolutely necessary. If you're going to be an efficient, good programmer, you've got to spend some time knowing how arithmetic calculations are performed in Java. Okay? So here's the next question. What is the biggest int that Java can represent? Because it can't go on for infinity simply because it doesn't have infinite memory. So there is a largest integer. Int data type. Now remember, there's going to be several different data types that we're not covering this year because we're going by the course requirements for AP Computer Science A. But what is the largest int? So the way that we can find that out is I'm going to create an int called max. I'm going to use the integer class, and I'm going to use the constant value defined in that class called max value. I'm also going to define an integer called min. I'm going to ask the opposite question, what is the smallest value? So let's print these out. So system.out.println, the largest int is, and then max, and then system.out.println, the smallest int is min. All right, let's see if this compiles. Good, it does. All right, let's run it. And so the largest integer that this computer can run is 2,147,483,647. And the smallest number that this computer can work with is negative 2,147,483,648. So now let's ask a new question. What if I add 1 to the largest int? What would happen? So system.out.println question mark plus max plus 1. Let's see what happens when I add 1 to the largest value. Right here. It cycled. In other words, it couldn't go any larger. So when I added 1 to the largest possible integer representation, it went all the way to the other extreme. It went to the smallest number. This is called arithmetic overflow. Arithmetic overflow. And you have to be aware of it because Java isn't going to throw an error at you. It's just going to cycle like this. So it could be possible where you write a program and by accident you're just adding numbers and they're getting larger and larger and larger. Your integers are getting larger and larger and larger. Well, if that happens, you're not going to get an error. So you've got to be prepared for arithmetic overflow. Okay. Well, okay, what if I subtract 1 from the smallest int? What do you think is going to happen? Plus min minus 1. All right, let's see what happens. Here we go. It cycled again, but this time it went from the smallest possible number to the largest possible number. And so that's what's going to happen with your arithmetic overflow. It's going to cycle. So be prepared for that. That could happen with you when you're making a program. Okay, we're almost there. So now we're going to talk about mixed mode arithmetic, which I really like because it's just so unexpected. Let's consider going back to the Fahrenheit equation that we worked with before. If you haven't worked with that problem, you can go back to the video which talks about converting Fahrenheit to Celsius. So, for example, I'm going to create a double F, which is 45 degrees Fahrenheit, and a double called Celsius, which right now I'm going to declare, but I'm not going to initialize. And what I'm going to do is I'm going to use the formula. Now the formula is 5/9 times Fahrenheit minus 32. And let's see, is that it? 5/9 times Fahrenheit minus 32? I believe that's it. Yes, that's it. And I'm just determined to misspell Celsius for some reason. I've got some neurons that actually think there's another C there in Celsius that I've got to override. Okay, there we go. Now, system, dot out, dot print line. And we're going to print out Celsius. And I'll tell you what, why don't we just make this 100 degrees Fahrenheit. All right, now it's not going to print what you think it might print. Some of you perhaps already see what's going to happen. But let's see what we get. We get 0. And 0 is not the correct answer. What happened? Well, what happened here is that 5 is an integer and 9 is an integer. And when Java performs integer division, it's not going to give you a decimal. It's going to give you another integer. So 5 divided by 9 will give you 0, because 9 doesn't go into 5 a whole number amount of times. So that's why it's going to give me 0. So what I have to do here is I have to introduce mixed mode arithmetic. There's a couple ways to do this. One is by changing the 5 from an integer to a double. Now this is mixed mode because I'm taking a double and I'm dividing by an integer. So what Java does is it says, okay, I've got two different types. I've got the integer type and the double type. So what I'm going to do is I'm going to let the final answer be the type that has the highest precision. Doubles have higher precision than integers because doubles have decimal values. So it's now going to take this and convert it into a double. Hey, there we go. 100 degrees Fahrenheit is 37.77 blah, 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 blah degrees Celsius. Now, typically what we do is we know that when the answer should be a double, we express our literals as doubles in this case. All right, but there is another way to deal with this. And so let's see how I would do this. Let's see if I can cast this division of 5/9 into a double. Let's just see if I can do that. I may have to write it a different way. No, it worked. So what this does is this performs the mathematical calculation and it doesn't store the value in an integer memory location. The cast here says, hey, I want you to prepare a double memory location for me and store this into the double memory location. So we don't lose our precision when we do that. So that's how you can cast an int to a double. by placing the word double in parentheses in front of the expression. And so I just killed two birds with one stone, mixed mode arithmetic and casting an int to a double. All right, God bless you, wherever you are today.